You spend a lot more time explaining your calculations than you spend doing your calculations. And so we need practice with interpreting what these things actually mean. So here we are looking at a math paper. Give me a word that I should search for that a math paper might contain. Derivative. Okay, so we're going to search for a paper that has derivatives in it, blah, blah, blah. Okay, on the non-integrality of certain generalized binomial sums. So whatever that means. Symbols, maybe 10%, but the rest of it's words. Second half of the paper, or first page, symbols, maybe half of it. Then words, symbols, words, symbols, words, numbers, words, numbers, words, word symbols. This paper is at least half words. Do you agree? There's a lot of calculation here, a lot of symbols. But then there's lots of explanations between and some pictures to help explain what's going on. If we pick a different one, this paper is overwhelmingly words. You see a calculation every now and then, but lots and lots of explanations, much more explanations than calculations. And this is a mistake people make. Both students and instructors will make this mistake, that they overemphasize the calculations, when in fact the calculations are important to be able to do correctly, but they're not the main thing you're going to be using this for. If you can calculate but you cannot explain, or you cannot ask the question, you're not going to be able to use this in the quote-unquote real world. So let's work on that skill for a little bit. I have given you a page where there are some statements about information, and those statements can be translated either to or from statements about derivatives. And the key thing that we need to remember as we're looking at this is, what do f of x and f prime of x actually mean? So just remember with me that if f of x represents something, a process where something is changing over time, then f of a, if x is equal to time, then f of a would be equal to the amount of whatever you're measuring at time a. And f prime of a is equal to the rate at which the whatever, I should have used w for whatever, rate at which the whatever is changing at time